Well, hello, my name is Eric Araujo and my partner is Pedro Zamora, and today we'll be talking about callosal disconnection syndrome.
Santiago. So, uh, for our background, we have, that during the 20th century, scientists, especially brain surgeons, came up with a new way to treat epilepsy by spreading the brain. And this came after the hypothesis, which could be seen as these seizures could be seen as electrical storms, which in a way overdrive the brain. So cutting this superhighway that is the corpus callosum, we could reduce the amount of neuron transit and thus reduce the seizures. And well, this actually in a way worked for these people who then were, the patients were called split brains. And well, they lived a normal life, but then doctors started noticing, and the patients too, some weird side effects, making it seem like the hemispheres of the brain were working independently. And this was later attributed to the lateralization of the brain, since information between the both hemispheres could not be shared directly between them.
So what we aim to do in this experiment in this paper was to compile some of the case studies studied by Dr. Michael Gazzaniga from Caltech University and see his results, his observations, and the performance of the several case studies that he analyzed throughout his 50-year span of working on corpus callosotomy and its adverse effects. And so that's what we did here. We believe studying this syndrome could represent a paradigm shift for the field of psychology, as it has some implications on what is the mind and how could theoretically the human mind be split between the right hemisphere and the left hemisphere. As you'll see later on, there are some kind of creepy and unexpected consequences of severing the communication bridge between both of your hemispheres.
Okay, so well, in the methodology for this study, we, as Eric mentioned, we studied the, we saw the papers from Michael Gazzaniga from Caltech, which were related from 1970 to 2018, and the respective cognitive functions. Here we have the table in which we can see 4 patients, WJ, JW, BP, and Kim-Pick. And well, we can see how some of them were affected in a positive way in conduct, perception, control, and memory by each one. But well, we can see that most of them actually recovered from epilepsy, which is something really shocking. And due to, well, that their conduct could be seen affected, but the epilepsy could be, well, it's actually really cured. Here we can see the infography with, well, telling us how these experiments were seen, how the left hemisphere would see nothing, but would actually talk. And well, the right hemisphere would be seeing this thing. Where we can see in the example of the image that says face, that is been seen by the left hemisphere, because that is the one that controls visual things, and the other well, the other one is the one who actually can talk, and well, it expresses how, well, the things. And in the other one, we can see that the right hemisphere is in face, but it cannot actually speak. So the subject actually says nothing because it's not saying anything, though it can draw what is being shown to him. And that's it.
Sure. For this experiment, it's important to remember that what you actually see is controlled by what you see in your right side, and the control of your right side of your body is actually directed by the left side of your brain and vice versa. So what Pedro was explaining in order to make it a little bit more clear, is that if you were to see the split brain patient on a table and maybe put a pile of objects over here, they will not be able to tell you that there is a pile of objects over here, because the part of the brain that speaks is the left brain, and the left brain can only see the right side of your vision. So right brain actually doesn't see anything. Sorry, left brain doesn't see anything. And so he speaks and he says, I don't see anything. However, your right brain, which controls the left side of your body, will actually pick the object because he is seeing that there is a pile of objects there, even if the other part of your brain cannot see it. So it's a little bit of a disagreement. There's some implications, and there are theories that stated it may be that each hemisphere of the brain is actually a different consciousness or a different part of you, in a sense, which are only able to communicate through the corpus callosum. And so severing this connection actually makes the right side of your brain mute. It can no longer communicate with the left side, which is the side that can speak. So the information it perceives can no longer be output to the world. It's a complicated topic because it has had some other consequences for split brain patients. For example, they are not able to choose what they want to wear for the day. If they think, oh, well, I want to wear this t-shirt, and they reach with the right hand to grab it up, their left hand, which is essentially their right brain, will say, no, you don't want that, and actually maybe drop it off with their hands or choose another thing. So they have kind of like these disagreements. They are also not able to learn new motor skills. Like if they didn't know how to juggle maybe some balls, they wouldn't be able to learn because their brains are no longer connected in a way that their motor skills can work properly, like in sync, the left and right side of their bodies. However, they can do some other stuff which we normal people, in a sense, that have not had a corpus callosotomy cannot do, like maybe draw with both of your hands, draw the same thing. And you know how it's difficult kind of do different things with each of your hands because you keep messing up? Well, that will be very easy for them. And that's actually some of the things that were proven, as well as some memory problems. They are not able to read as well as they were. They are not able to recognize faces of their friends and families as well as they were. And all of this has to do with how the brain is separated. Like some of its functions are predominantly found in the right hemisphere, and some of its functions are predominantly found in the left hemisphere. So severing these connections is really harmful for it. However, what we found most important is that, or most surprising, is that throughout the years that Mr. Gazzaniga studied these patients, they actually kind of recovered. Their motor skills kind of improved, and that's what we can see in the table, that they eventually got better over time, which wasn't expected at all. And so to conclude, we want to say that this topic is a bit complicated, and we believe that it truly can represent a revolution for the psychological field in terms of how we understand the human mind. But there's a lot of obstacles in the way. For example, we don't have any more corpus callosotomy patients we can test this on because the procedure was stopped a few years ago when we eventually found our medicine evolved to a point where it was no longer needed to sever the middle part of the brain in order to stop seizures. Now we have medication for that. And so we have that problem in a way. That's kind of the biggest issue. We can no longer study this unless there's someone willing to do corpus callosotomy. But if we were to kind of continue studying this, we will propose that larger focus on brain plasticity and how the brain can correct itself. We think it will be really useful, and more insight into maybe brain lateralization as well. Like we need to still further test what we can and we cannot do. So now, one of the largest theories states that maybe we do have two separate consciousness. However, one of them is mute, and it has no, well, nothing to do but cooperate with the part of our brain that can actually speak and is responsible for most of social interactions. So yeah, that's basically it. Thanks for your attention.
Excellent job, guys. Excellent job.